listening to Cassphere Podcast.
Welcome back to cassphere. Now, before we really get going, let me just clear the air for anyone who might have gotten us mixed up with some other shows last time. We are the Cassphere Podcast.
And I'm Olive.
And I'm Truffle. Glad you're with us today. Remember back in episode 3 when we promised we'd do a deep dive into self-attention and NLP?
Oh, yeah.
Well, get ready, because that's what we're doing.
It's a fascinating topic, and it's one that's really pushing the limits of how AI understands and interacts with language.
Okay, so for anyone who's maybe just tuning in for the first time, let's start with the basics. When we read, we don't give every single word the same amount of weight, right? Like we naturally kind of focus on the words that are carrying the most meaning.
Exactly. And that's essentially what attention is in the world of natural language processing. It's giving AI models the ability to focus on the most relevant parts of a text, to understand the context and the meaning.
So it's like giving AI models a superpower to zero in on what really matters in a sentence.
Yeah.
But how do they actually do that?
Yeah, that's where things get really interesting. One of the big innovations that made this possible is an architecture called transformers.
Transformers. I remember when that paper came out. I mean, the title itself was just so bold. Attention is all you need. It's like they knew they were about to revolutionize the field.
And they totally did. The transformer architecture utilizes the attention mechanism in a really clever way. At its core, it uses an encoder-decoder structure.
Okay, hold on. For those of us who aren't AI engineers, can you break that down? What does an encoder-decoder do?
Sure. Think of it this way. The encoder takes the input text, let's just say a sentence, for example, and it processes it to understand the meaning and all the relationships between the words. And then the decoder takes this understanding and uses it to generate some kind of output. That could be a translation or a summary or even an answer to a question.
So if we were to imagine it like a factory, the encoder is like the assembly line where all the raw materials get processed, and the decoder is where the final product comes together.
That's a great way to think about it. And within this encoder-decoder structure, we have our star player, the self-attention mechanism.
Yes. Self-attention. This is what we've been waiting for. Can you give us a sneak peek into how it works?
Well, at its heart, self-attention allows the model to understand the importance of each word in relation to every other word in a sentence. It doesn't matter how far apart they are. Imagine working on a giant jigsaw puzzle, but you're thinking about all the pieces at the same time, not just one at a time.
Okay, that's a great visual. But I have to confess, my brain works better with step-by-step breakdowns. So what are the steps involved?
All right, let's break it down. It starts with something called vectors. For each word in the sentence, the model creates 3 vectors: a query, a key, and a value.
Query, key, value. Those sound kind of familiar from when you're doing searches. Is there a connection?
You're exactly right. Think of the query like your search term. The key is like the label on a file. And the value is the actual content of the file.
Yeah. Got it. So the query is what the model's searching for. The key helps identify where the information is. And the value is the information itself.
Exactly. It's a super efficient search and retrieval system that all happens inside the model. And with these vectors, we can start to see how the relationships between words are understood.
This is where it gets really interesting, right? What's next?
Okay, so next, the model calculates what's called the dot product between the query of each word and the key of every other word.
Hold on. For those of us who don't speak math, could you simplify that? What's a dot product?
In simple terms, the dot product basically tells us how similar 2 vectors are. So in this case, it tells us how much one word is paying attention to another word.
So it's like every word is whispering secrets to every other word, and we're trying to see how closely they're listening.
That's a great analogy. And just like in a real conversation, some words are more attentive than others.
So these attention scores tell the model which connections are the most important.
Yes. But we're not done. These scores need to be refined.
Refined? How do we do that?
First, we scale them down to make sure everything stays balanced. Then we apply a mathematical function called a softmax function.
Okay, I'm going to need some more help with that one. What does this softmax function do?
Okay, so think of it like this. You have a bunch of scores, and you want to turn them into probabilities that all add up to 1, like slices of a pie. That's what the softmax function does. It takes those raw attention scores and transforms them into attention weights.
So we're creating a weighted average of how much attention each word should pay to all the other words.
Exactly. And then we use those attention weights to calculate a weighted sum of all the value vectors. This gives us the final representation of each word, taking into account how it relates to all the other words in the sentence.
Wow, that was a lot. But the cool thing is that this process is so similar to how we understand language. When we read, we don't just read words one by one. We consider their relationships and the context they're in. It's almost like we're calculating our own internal attention weights as we read.
Right. And that's one of the things that makes self-attention so powerful. It's mimicking the way our brains work. It allows AI to understand language more like we do. But wait, there's another layer to this that makes it even more interesting.
Wait, there's more. My brain is already doing gymnastics with all this information. What else is there to learn about self-attention?
Well, what if there are multiple ways to interpret a sentence, multiple angles to look at it from? That's where multi-head attention comes in.
Multi-head attention. Okay, I'm listening. What does that mean?
Imagine we have a team of really smart detectives, and they're all looking at the same sentence, but each from their own unique perspective. That's basically what multi-head attention does. It's like having multiple experts inside the model, and each one focuses on something different.
So like a brainstorming session for AI where they're considering different perspectives.
Exactly. We're getting a much deeper and richer understanding of the sentence by looking at all these different types of relationships.
Okay, I'm starting to see how powerful this multi-headed approach is. But how does it actually work? Do we have multiple sets of those query, key, and value vectors all going at once?
Yep. In multi-head attention, we run the entire self-attention process several times, each time with different parameters, like having different lenses all focused on the same sentence.
So we're running multiple self-attention operations all at the same time, and each one picks up on different details.
Exactly. And then once we have the results from each of these heads, we combine them to get a really full and complete picture of the sentence, like we're putting together all the insights from our detective team.
This is getting really sophisticated. It's amazing how much goes into building these models.
And the best part is that all of this complexity leads to some pretty amazing results. Self-attention, especially in its multi-headed form, has had a huge impact on NLP.
Well, I can't wait to hear more about this impact. What are some of the ways self-attention has really changed the game?
Okay, well, first of all, it's helped us figure out how to deal with those long-range dependencies we talked about. Now words can talk to each other even when they're far apart in a sentence, which means we have a much deeper understanding of the meaning.
So no more AI forgetting what happened at the beginning of a really long sentence. That's a win for everyone.
Exactly. And remember how we talked about transformers being able to process information in parallel? Self-attention is a big part of that, too. It makes things much faster compared to the old models that had to go through everything step by step.
It's like going from reading word by word to understanding the whole picture at a glance. That's incredible.
And here's something else that I think is really interesting. It's also making AI more interpretable.
Interpretable, do you mean we can actually see what the AI is focusing on? Like you can read its mind?
Well, sort of. With self-attention, we can actually see the attention weights. That can tell us which words the model thought were the most important when it was analyzing a sentence. It's like having a window into its thought process.
That's amazing. So we can actually understand why it's making certain decisions.
Exactly. This is really valuable, especially if we need to debug a model or figure out why it's making a certain prediction.
Like it's explaining its reasoning to us, which is super important for making sure that these models are being used responsibly.
Absolutely. And finally, self-attention is very scalable. This means we can use it to build larger and more complex models that can handle even longer pieces of text.
So self-attention is really the gift that keeps on giving to the field of NLP.
That's a great way to put it. And I, for one, am really excited to see how self-attention continues to evolve and change how we interact with language through AI.
You've definitely convinced me that this is a big deal. I bet our listeners are just as amazed by its potential as we are. But before we get too carried away, let's take a second to recap what we've learned so far.
Sounds good. It's been a long journey already.
We started by talking about the idea of attention and how it's like what we do when we read. Then we explored the transformer architecture and its key component, the self-attention mechanism.
Yeah, and we even went into the details of multi-head attention where different perspectives all come together. It's incredible how much is packed into this one concept.
It really is. But for now, let's let all this information sink in a bit. When we come back, we'll talk more about the amazing impact self-attention is having on the world of NLP. Stay with us. Before we jump in, just a quick heads up. We're looking for an awesome collab here at Cassphere.
Nice.
We can advertise your product, introduce your incredible idea, even do a deep dive into your product features.
Oh.
So if any of that sounds right up your alley, shoot us an email at cassphere.contact@gmail.com.
Welcome back. I'm really excited to talk more about how self-attention is impacting NLP.
Me too. Before we took a break, you were saying that it's been a real game changer. Could you give us some specific examples of how self-attention has made AI better at working with language?
Well, let's take machine translation. Have you noticed how tools like Google Translate have gotten so much better over the past few years? They're producing much more accurate and fluent translations, and that's largely due to self-attention.
Oh, that's interesting. I hadn't really made that connection before, but it makes sense. Self-attention's ability to handle those long-range dependencies would really help with translating, especially for languages that have really complex sentence structures.
Right. It lets the model keep track of how words relate to each other, even if they're really far apart, which is crucial for getting the meaning right when you're translating between languages. And it's not just translation. Self-attention is also leading to improvements in text summarization.
So that's why the summaries I'm seeing from AI tools are starting to look less like a random bunch of keywords and more like something a human wrote.
That's exactly it. Self-attention helps the model pick out the most important parts of a text and then condense them into a short and meaningful summary. And then there's question answering.
Oh, yeah. Like those virtual assistants and chatbots that can answer our questions in a really thorough and accurate way.
Yeah.
Is self-attention involved there too?
Definitely. Self-attention is helping the model to understand all the subtle details of the question and then find the right information within a text to give us a really good answer. It's really changing how we interact with computers.
It's amazing to think about how all these advancements are changing how we get information and how we talk to each other. And it all goes back to this core idea of self-attention. It allows AI to understand language more like we do.
I know, it's pretty mind-blowing. But here's something else to think about. Self-attention isn't just making AI smarter, it's also making it more efficient.
More efficient? How so?
Well, remember how we were talking about self-attention enabling parallel processing? This means that the model can look at different parts of a sentence at the same time instead of having to go through them one by one like older models used to.
So it's like having a whole team of processors working on different parts of a problem all at once. That's why things are getting so much faster.
Exactly. And this efficiency isn't just about speed. It also means that we can build more complex models without sacrificing performance. It's allowing us to tackle some really tough NLP tasks that we couldn't even attempt before.
So it's not just about doing things faster. It's about opening up new possibilities with AI and language. What an exciting time to be alive.
You said it. But in all this excitement, it's also important to remember that self-attention, like any really powerful tool, comes with some things we need to think about carefully.
What do you mean?
Well, while self-attention has brought about all these incredible advances in NLP, it's crucial to use it responsibly and to watch out for biases that might creep in.
That's a really good point. We know that AI models are trained on massive amounts of text data. And if that data has biases, then the model might accidentally learn and perpetuate those biases.
Exactly. For instance, if a language model is mostly trained on text that connects certain jobs with a specific gender, then it might show gender bias in its outputs. It's something that researchers are actively working on, but it's crucial to be aware of these potential issues.
So it's a reminder that while we're celebrating all the great things AI can do, We also need to be very careful about how it's used. It's up to all of us, the researchers, developers, and users, to make sure AI is being used fairly and responsibly.
I completely agree. It's a shared responsibility, and the better we understand how these technologies work, the better we'll be able to navigate these challenges.
Absolutely. This conversation has really shown how important it is to stay informed and involved with the world of AI. It's moving so fast, and we need to understand these changes and participate in shaping how things develop.
I couldn't agree more. Knowledge is power. And the more we know about these technologies, the better we can understand the opportunities and challenges they present. To all our listeners out there, we encourage you to keep learning, exploring, and asking questions.
The world of AI is incredibly interesting. There's always something new to learn. And who knows, maybe one day you'll be the one making the groundbreaking discoveries.
And if you have any thoughts or questions along the way, feel free to reach out.
You can find us at cassphere.contact@gmail.com.
We always appreciate hearing from our listeners and learning from your insights.
So until next time, stay curious, stay engaged, and keep exploring the incredible world of AI.
Bye, everyone.